Hi, in this video we're going to learn the elimination method to solve the simultaneous equations. Let's look at this example now. Now remember, I need two equations to find the values of two unknowns. If I have only one equation with two unknowns, I won't be able to find the value of each unknown. I can make predictions, but I won't be able to know which of these predictions are correct. So now I'm going to use the elimination method to solve these simultaneous equations. The idea is that if I get rid of one of the unknowns, I can end up with a linear equation with one unknown, which I know how to solve, right? So what I'm going to do is I'm going to add these two equations and try to end up with an equation with one unknown. Now, luckily, I have plus y and minus y here. You can easily figure out that when I add these equations side by side, y's will cancel each other out because one of them is plus y, the other one is minus y. So they cancel each other out, and I end up with x plus x being 2x, and on the right hand side it's 12 plus 6, which is 18. So I'm doing addition here. Now, the equation I get is 2x equals 18. So I'm going to divide both sides by 2 to leave x alone. So I'm solving for x. So I find that x is 9. Once I find x to be 9, I can substitute the x value either in the first equation or in the second equation. It doesn't matter which. And then I can calculate the value of y. So it's going to be, let's use the first one. So let's use the first one. It's going to be, x plus y equals 12 instead of x. Now I'm going to write down the value of x, which is 9. So it is now 9 plus y equals 12. So if you take away 9 from both sides, you'll find that y is nothing but 3. This is the same if you were to substitute here. 9 minus y is 6. It is a second equation. So take away 9 from both sides, you're going to end up with minus y equals minus 3, which means y equals 3, right? So it doesn't matter which equation you choose. You just substitute the value of the unknown you found into it so that you can find the value of the other unknown. Now, let's go on with an example which is slightly harder. Right, so in this one we have 2a plus b equals 7, a plus b equals 4. Now, if I go with the elimination method and add the equations side by side, I'm going to end up with 2a plus a being 3a, b plus b being 2b equals 7 plus 4 equals 11. Now, when we look at this equation, we still see that there are two unknowns in this equation, so I can't solve this equation. So there's something wrong going on here. Apparently, I'm not going to be adding these equations like that. Now, in some books, you're going to see that the simultaneous equations are solved by subtraction method. Well, I don't prefer this because then it creates some confusion, because in such simultaneous equations you have to do addition. If the simultaneous equations look like this, then you have to do subtraction. So this is slightly confusing, so I always prefer to stick to addition. But apparently addition does not work. So I have to tweak one of these equations a little bit. So this is what I'll do. Instead of adding them immediately, I'm going to follow a slightly different method. Now the difference here compared to the previous simultaneous equation example is that we have an addition sign, a plus sign here, right? In the previous example, this was a minus, so that I was able to get rid of those b's or y's in the first example. So this is not the case at the moment. I can't cancel these out when I add them. So I have to change signs. So follow this up. So first of all, I have to decide which of the unknowns I'd like to eliminate, All right, so I'll go with b, and I'm going to multiply the second equation by -1. So let's rewrite the equations now. It's going to be the first one being the same, right? 2a plus b equals 7. The second one will be -1 times a, -1 times b minus b equals -1 times 4 minus 4. Basically, I changed the sign of each term. Now I'm ready to add, because when I start adding, it's going to be 2a plus minus a, meaning 2a minus a, which is a, and b plus minus b, so they cancel each other out. So one of the unknowns are gone. And here it is 7 plus minus 4, meaning 7 minus 4, which is 3. So I found the value of a. Now I can use one of these equations to substitute the value of a so that I can calculate the value of b. So it's going to be like, let's choose a second one, 3 plus b equals 4. Then I'll take away 3 from both sides, ending up b being 1. So this is how I can solve these simultaneous equations. One more example. Right, in this one, again, if I directly add the equations side by side, I'm going to end up with 3m plus 2m being 5m, minus 2n plus n being minus n, and 11 plus 12 equals 23. As you can see, I still have these two unknowns in the resulting equation. So it seems there is a problem. Well, the signs are different, so why didn't I get rid of n immediately? The problem is we have minus 2n here, whereas we have just n here. So to be able to cancel these out, I should be able to have 2n here. Okay, if I need 2 in front of n, then why don't I just multiply the second equation by 2? Okay, let's give it a try. If I multiply the second equation by 2, well, I have the first equation the same, 3m minus 2n equals 11. And then 2 times 2m is 4m. 2 times n is, well, plus 2n equals 2 times 12 is 24. Now, if I add these equations side by side, then I'll be able to cancel minus 2n and 2n. So it's going to be 3m plus 4m, which is 7m. And on the right-hand side, it's 11 plus 24, which is 35. So if I divide both sides by 7, I can find the value of m being 5. Now that I know what m is, I can substitute it into any of these two equations. Let's pick the first one now. So it's going to be 3 times 5 minus 2n equals 11. So this is 15 minus 2n equals 11. So if I take away 15 from both sides, I'm going to end up with 2n minus 2n equals minus 4. If I divide both sides by minus 2, I'll end up with n being 2. So these are the values of m and n. So basically, the elimination method works when you have one of the unknowns with a different sign. You can see that it is minus here, it is plus here, and the coefficients are the same. So it's minus 2n plus 2n, they cancel each other out, right? So if the given simultaneous equations are not like that, then you can just adjust one of the equations, or maybe in some cases both equations. You can expand them with a coefficient, you can make a multiplication, right? And you can just make sure that the signs are different and the coefficients are the same. So you can just cancel these unknowns out. Once you cancel one of the unknowns, you end up with a linear equation with one unknown, which you can easily solve. And then once you find the value of one unknown, you can just make a substitution either in the first equation or the second equation to end up with the second unknown. So this is the core of elimination method. One more example. Right, in this example, we have 4x plus 3y equals negative 1, 2x plus 4y equals negative 3. Obviously, I have to tweak these equations before I can add and eliminate one of the unknowns. Because, one, the signs are not different. It's 4x and 2x, they are both positive. And 3y and 4y, they are still positive. They are not different signs there. And two, the coefficients are not the same. It's 4x and 2x. It is 3y and 4y, so I can't eliminate any one of those unknowns, so I have to tweak them. Now, I have to choose. If I choose to get rid of y, then I must multiply this first equation by 4 and the second one by 3. Now, it doesn't matter which of these multipliers you're going to choose, but one of them must be minus because you have to change the sign as well. As you can see, both are plus. So if you multiply one of these equations with a negative multiplier, then this sign will change. All right, so you can go with this one being negative if you'd like, or you can go with minus 4, it doesn't matter. Or instead of this, you can decide to get rid of x's. Now notice that this is 4x here and this is 2x. So if I just multiply the second equation by 2, I will make both coefficients the same, right? That's going to be 4x and 4x. And if I just change the sign of the multiplier to negative, then I'm going to end up with a negative coefficient here for x. So let's try this. So if I multiply the second equation, let's try the first one first. It doesn't change, so it's 4x plus 3y equals negative 1. And then minus 2 times 2 is minus 4, so it's minus 4x. Minus 2 times 4 is minus 8y. And minus 2 times minus 3 is 6. Now you can see that 4x and minus 4x cancels each other out when I start adding the equations side by side. Then I have 3y minus 8y, so it's 3y plus minus 8y ending up with minus, so it's going to be minus 5y, and here it is minus 1 plus 6, so I end up with 5. If I divide both sides by negative 5, I end up with y being negative 1. So this is the value of y. Once I find the value of y, I can just go with any of these equations to substitute and find the value of x. I'm going to go with the second one. So it's going to be 2x plus 4 times negative 1 equals negative 3. So it's 2x minus 4 equals negative 3. So if I add 4 to both sides, I'm going to end up with 2x being 1. And if I divide both sides by 2, I end up with x being 1 over 2. Now sometimes you may prefer to write this as, 0.5. But generally I don't prefer decimals because not every fraction gives you a nice decimal like that. If we were to end up with 1 over 3, you should be writing a recurring decimal, 0.3 recurring, right? So unless the question requires you to write a decimal, don't go with a decimal, just keep it as a fraction. And also you can see that you can end up with fractional values when you're calculating or solving for the unknowns here in simultaneous equations, all right? So this is not something wrong. Now, before you go with the exercise set, I suggest you solve these examples by yourself and make sure that you find the same answers. And also I suggest, for example, for this last question, we discussed that we could also get rid of y. So why don't you just try multiplying this by negative 4 and multiplying this by 3? So try this version with the simultaneous equations and try to get these values for x and y. And then once you feel confident, you can just start with the exercise set. That's my suggestion. But if you feel confident already, you can just hit with the exercise set and start solving. Right, here are 5 simultaneous equations for you. Please solve these on your books and submit your answers online. Now, keep in mind that technically speaking, it doesn't matter which of the unknowns you choose and eliminate, okay? But if you choose wisely, it's going to be easier to solve these simultaneous equations. So make sure that you have different signs and the same coefficient, okay? For example, in question 4, I'll give you a hint. In question 4, it is easier to get rid of p, right? Because it's minus 3p here in the first equation and it's plus 3p here in the second equation. But of course, if you choose to eliminate k, technically speaking, that is possible. But eliminating p is easier. So make your choices wisely, right? Different signs, the same coefficient. If the coefficients are not the same, make them the same, as shown in the examples in the video, right? Thanks for watching.